I've got some functions here that don't get much love in a regular calculus course, but I think they're pretty important, so let's talk about them. Max, min, ramp, step, and sine. Let's talk about max first. If I just said, what's the max of 3 and 7, you'd say, well, 7 is bigger than 3, so the max of 3 and 7 is 7. How about the max of 3, 7, negative 10? Well, you can take the max of more than just two numbers at a time. This would still be 7 because 7 is bigger than negative 10. It's what's closest to positive infinity. That's the max. What about the max of 0 and 5? Hopefully you'd say 5. How about the max of 0 and negative 100? Well, 0 is larger than negative 100. 0 is closer to positive infinity. So this is just 0. So we can take all those ideas and boil them into a new common function called max of 0, x. And if we plot that, actually you need to be a little careful in plotting it. So there's my axes. For x greater than 0, which is bigger, 0 or x? Well, for x greater than 0, x is greater than 0, so you just get x. So you just get y equals x over here, a 45-degree line. For x values less than 0, which is bigger, 0 or x? 0 is bigger, so you just get 0 regardless of what x value you put in less than 0. So instead of continuing on down here, you get a flat line like that. So this has a 45-degree sharp angle at the corner. You could say max of 0, x is equal to x if x is greater than 0, 0 if x is, let's try that again, x is less than 0, and if it's equal to 0, well, either one, because x is equal to 0. So this is called a ramp function. And it's useful if you have something where you kind of throw a switch and stuff starts accumulating and just grows linearly. It's also called a ReLU function, rectified linear unit, in machine learning. They're quite popular there. Machine learning is a branch of artificial intelligence or data science or statistics or something. So that's the plain max function, or the max 0x function. You could also call it the positive part function. So some people write it like x sub super plus or x sub plus. So if x is positive, it is its own positive part. If x is negative, how much positivity is there in it? 0 positivity in it. So you just get that. So that's the ramp function. What happens if we take the max of 0, x and divide by x? Well, if x is less than 0, you're just taking 0 divided by x, which is 0. And I'll do this again in pencil so it's easy to see the axes. So over here, you're just getting all zeros again. And if x is greater than 0, then you're getting x divided by x, which is just 1. And what if x is equal to 0? Well, then you're getting 0 over 0, which is kind of undefined. So we sort of have holes there. Sometimes we put a dot in the middle at 1/2. Sometimes we put the dot up here. Sometimes we put that dot down there. It doesn't really matter. Each field has its own conventions. This function has its own name. This is called the step function. And it's actually named after, I guess, the person who invented it or made it popular, whose name was Heaviside. So it's also called the Heaviside step function or unit step function because it goes up by 1 unit. I think it's kind of funny that the person's name was Heaviside and this function looks like it's heavier on one side than the other. So it's like turning on a light switch. You have 0 current and then bang, all of a sudden you have full current, at least in a very simple view of light switches. What's the derivative of the ramp function? Can you take a minute to think about that? I'll write that question here. Another useful function is min, just like max. So you can take the min of two things. If I needed to put a cap of something, like let's say 10 on a value, so I was going to control something, but the number was never allowed to go larger than 10. I could say min of 10 comma x. If x is less than 10, like 0, I'll just get 0. I'll get 1, 2, 3, all the way up here. This would actually continue over there, but usually I wouldn't care about that. But once that number crossed 10, then the smaller of the two things is 10, so it would just continue on over this way. So that's a way of putting a cap on something. So the min function is also handy. There's another function called sine of x, or sometimes it's abbreviated SGN of x. It's not our trigonometric sine, it's sine like, is this number positive or negative or 0? So it's defined to be plus 1 if x is positive, minus 1 if x is negative. So what's the sign of a negative number? It's negative, and just negative 1. And if x is 0, then it's not a positive or a negative number, so its sign is 0. So we can graph that pretty easily. So come in here at negative 1, go out here at positive 1, and have a filled dot right there. Most languages have this, like Excel has this, Desmos has it. If you don't have it in a particular language, you can kind of approximate it by doing absolute value of x over x. You can see how that would pretty much cancel, and you'd be left with 1 if x was positive. If x was negative, then you'd have the positive version of it divided by the negative version of itself, so you'd get negative 1, but then that fails at 0. So I had a student once ask me, so those are fun things to play with, but those aren't real math, right? Like those aren't real functions. And the answer is, well, if they're implemented in common software, then they are real functions. That's kind of being sarcastic, but it's also kind of being true. So let's go play with them in Desmos just to see if they're real functions or not. All right, so let's say max of 0 comma x. Well, that's a ramp function, all right. If we divide that by x, we get the, here, let's show it bolder. We get the Heaviside step function. It's 0 until you turn on the switch, and then it's 1 from then on out. We could say max of, I used 10 in my example, but we can use min of 1.5 comma x to show capping a growing value off at some other value. You can even, if you want to bound something between two values, you can say like max of 0 comma, but then instead of just using x, you can say min of 1.5 comma x, and that will never get below 0 and never get below 1.5. So that's kind of fun. What else do we say? Sine of x seems to be working okay. Let's actually define a function here. And then we can say what's sine of 0? It's 0. Sine of negative 3 is negative 1. Sine of positive 3 is 1. Sine of 0.0001 is positive 1 and negative. And I'm not sure whether Desmos allows SGN. No, I can't. I guess it has to be SIGN. So different languages will have different syntaxes for it, but if it's implemented in common software, it must be a real function, right? So these are often used in modeling. If you want to avoid an if statement, if you want to say something like, if x is less than 0, then do this, otherwise do that. Sometimes you can do that with max and abs and sine and stuff. All right.